So 634 millimeter mercury divided by 760 millimeter mercury for 1 atm. Your answer will be 0.834. Right? Are you okay for this? I hope everybody can figure out this type of problem solving. This is the easiest. Okay, cannot be easier than this. Okay, you okay? Now take a look.
You get a question back there.
Oh, sorry.
You get the 760 problem. That's the ATM equals the ATM. One.
Yeah, 1 ATM is 760.
You need to remember this. 1 ATM is 760 millimeter mercury. You're required to remember this. Another question? No? Okay, then next. Next is 32. 32, given that 6.9 moles carbon monoxide are present in a container of volume 30.4 liter. What is the pressure of the gas in ATM if the temperature is 62 Celsius degree? Ask you what is the pressure? Ask you calculate the pressure. As I said, for any problem solving, if gas is involved, you need to think about ideal gas equation first, right? Except this is a convert pressure into different units. You're not use ideal gas equation. This is just different pressure unit. So ideal gas equation, right? PV equal to nRT. Okay, again, everybody must remember this equation. Ideal gas equation. Okay. For this case, ask you pressure. Ask you pressure, then you need to know everything else. Because one equation, you can only solve one variable. Okay. So V, tell you, is known value, right? V is a known value here. Let me use different color. V is a known value, 30.4 liter. So tell you what this is. N is more, 6.9 more is a known value. What this is?
What is the R?
R.
Constant?
Yes, gas constant. R is a known value. During the test or quiz, I will provide you this number. Don't worry. It's a constant, is a known value. Okay, so R is a known value. How about T? T tells you. Yeah, temperature. T you need to convert to Kelvin. But anyway, this is a known value. Just convert to Kelvin, right? So you see, for this equation, everything else are known value except P. Of course, we can solve for P. Then both sides divided by V. So again, comes out the first class, tell everybody you need to know how to solve type of equation, right? Otherwise, you're not ready to sit in this class. It's another example, right? So both sides divided by V, you solve for P. So P equals to nRT divided by V. Now just plug in the number 10, 6.9 more. R.08206 unit is liter ATM per mole per K. T, 62 degrees Celsius. You need to convert it to Kelvin. 62 plus 273.15. If you use 273, that's fine. But you cannot use 62 directly. The reason is this R value is per K, is not per Celsius degree. Okay. V 30.4 liter. Now use calculator. You can easily find the pressure will be 6.24 atm. So everything else considered. More considered is per mole. Liter considered is liter. K considered is per K. Only left over atm. Pressure is atm. Right? 32. Are you okay with this? Do you have a question? Yes or no? Okay, no, no, you are fine. Okay. Then take a look what's next. 32. You have any question? No? Okay. Then 43. Okay. 43, a volume 0.28 liter of gas. 0.280 liter of gas. At STP with this mass is 0.4 gram. As you calculate the molar mass. Okay, molar mass, we use MW instead of M because in chapter 4 we use M for molarity. Okay, don't confuse these two. It's different symbol. Okay, as you calculate the molar mass, so formula, how to calculate the molar mass? Right. This these two equivalent, just rearrange, right? This is calculate the density. This is calculate the molar mass. So in order to calculate the molar mass, we must know T, R, T, and P. Okay. We must know D, R, T, and P. R is a gas constant. This is always a known value, right? How about the TP?
Isn't temperature at that 0 degrees Celsius?
Yeah. This is STP, means standard temperature and pressure. Standard temperature, 0 degrees Celsius, convert to Kelvin, 273.15 K. Standard pressure, 180. Okay, you must remember this. Whenever there's STP, means T is 0 degrees Celsius, P is 1 atm. Okay, so T, P, both known value. No, left over D. D then tell us mass and volume. Right? We can calculate the D. So we need to calculate the D first. D is the density, yes. Density comes from mass over volume. So mass is 0.4 gram. Volume 0.28 liter. Use calculator, find out this density. Use calculator and get it. Okay. Now we can use this formula to calculate the molar mass. D 1.43 gram per liter, R 0.08206 liter ATM per mole per K. And T, be careful, you cannot use zero. If you use zero, then everything is zero, right? Converted to Kelvin. 0 degrees Celsius is converted to Kelvin. 0 plus 273.15. This is Kelvin. Then P is a 1 ATM. Right. Molar mass, what the unit you expect? Gram per mole, molar mass, right? Gram per mole. Is this true? ATM cancel this ATM. Kelvin cancel this per Kelvin. Liter cancel this per liter. Only left were gram per mole. Huh? So this. Only left over gram per mole. Use calculator. You can easily get the molar mass will be 32. 32, mostly oxygen gas. Right? Of course, here didn't ask you identify which gas. Only asking you calculate the molar mass. Are you okay with this? Then show you another 57. 57. Looks like too small. Okay. 57, a mixture of gas contains CH4, C2H6, and C3H8. If total pressure is 1.5, ATM, and number of moles of gas present 0.31 more CH4. CH4 is 0.31 more. C2H6 0.25 more. C3H8 0.29 more. As you calculate the partial pressure of each gas. Okay. Partial pressure equal to mole fraction times total pressure. Right, so we need to figure out the mole fraction first. And mole fraction equals to moles of that gas. Use CH4. Then CH4 mole divided by total mole. Mole of CH4 tell you 0.31. Total mole, you add all three moles together, right? 0.31, 0.25 plus 0.29. Right. This is mole. This total mole. So mole cancelled. No unit. Mole fraction, no unit, just a pure number. Okay. Use a calculator, we can easily get this mole fraction. 0.365. Okay. Then partial pressure of CH4 will be mole fraction of CH4 times total pressure. Mole fraction we just calculated. Total pressure 1.5. So will be 0.548 atm. Okay. Then similarly for C2H6, you need to calculate mole fraction first. Moles of C2H6 divided by total moles. Mole C2H6 is 0.25. Total moles same as here. 0.31 plus 0.25 plus 0.29. This will be 0.294. Okay. Then similarly as the CH4, the partial pressure of C2H6 will be mole fraction of C2H6 times total pressure. Mole fraction C2H6 we just calculated 0.294. Total pressure 1.5 atm. Then partial pressure will be 0.441 atm. Then similar for C3H8. Mole fraction will be moles of C3H8 divided by total moles. C3H8 moles 0.29. Total mole exactly the same as other two. We just use 0.31 plus 0.25 plus 0.29. This will be 0.341. Okay. Then partial pressure of C3H8 will be mole fraction of C3H8 times total pressure. Mole fraction 1. Total pressure 1.5 atm. Partial pressure of C3H8 will be 0.512. atm. Do you have any other? Oh, first, can you understand this? And do you have any other question?